Again, here we are in my next video in sampling techniques and data collection. In this video, we're going to learn about the types of sampling techniques. And if you're new to my playlist, we are in the playlist of psychological statistics. So we want to know that there are different types of sampling techniques. Basically, we branch them out into two. We have the probability sampling, and its a complement, which is the non-probability sampling. So we're going to discuss each of them in detail, but in this video, we're going to preserve this in the first batch of probability samplings. Or if we can finish it, so why not all of the probability samplings then? So the probability sampling, it has a purpose why it's called probability sampling. As we know, probability is something that deals with chance. So the thing here with probability sampling is that each element in the population is given a chance, which we say that it is non-zero. Everyone in the population is given a chance to be part of the sample, which makes things fair because everyone in the population should be given the chance, right? Since it's part of their, since they are part of your population, say so they should have this chance to be part of your sample. This minimizes, if not eliminates, what we call selection bias, and this is actually ideal, everyone, if there is a need for you to generalize the results and conclude in your study. Inferential statistics, therefore, can be used in arriving at generalizations or conclusions about the population based on sample data. So it is actually a must, though some are still following otherwise, that when you are applying inferential statistics, it is a must that probability sampling, your methodology in the participants part of the your methodology should be based on probability sampling. So therefore, you cannot use convenience or purposive sampling, for instance, if you have questions like significant difference relationship in your statement of the problem. So it should be that at least it should be probability sampling, or else there will be a misalignment of your generalizations, hence giving us erroneous or mixed results compared to other studies. So again, if you have inferential statistics or inferential analysis in your statement of the problem, please refrain from using non-probability sampling, and always, okay, always use probability sampling. Now, we know that there are different types of probability sampling. We have simple random sampling, systematic random sampling, stratified random sampling, cluster random sampling, and multi-stage random sampling. So we will discuss them in great detail, and I mean each one of them. Um, we'll start first with simple random sampling. In some books, they call this SRS, or simple random sampling. Okay. Here, in simple random sampling, everyone or everybody is given an equal chance to be included in the sample. This is actually the foundation of all the sampling procedures that we have. Though there are assumptions when we use this. We use this first when the population is homogeneous, wherein, they are kind of the same, each one of them. And when a sampling frame is available, i.e., a sampling frame is a complete and updated list of the population. So if you know the list, if you can produce a list of everyone in your population, well, there's no problem. You may just use SRS. Actually, SRS is stronger than one can think, one thought. So what are the procedures in making use of the simple random sampling? You may use either of the procedures, lottery/fishbowl, though in some books they call this lottery method or fishbowl method. The proper name for this is simple random sampling. Or you can also make use of random number generators. In Microsoft Excel, I use that as well. Or actually, there are plenty of random number generators online. Just Google RNG or random number generator, and it will produce you a lot of websites, a lot of links that can randomly generate numbers for you. And those generated numbers can become your sample or parts of your sample. So that's SRS. Let's go now to systematic random. So systematic random is, there's a system, and that system is, you select every kth element of the population. So it's still a must for you to have a sampling frame, because from that sampling frame you have the list, and then you'll be skip counting. Basically, systematic random sampling is skipping count, okay, or rather skip counting. We use the systematic random if we know that the population is homogeneous, and that there is no suspicion that in your sampling frame, in your list of all the names of the population, there is no pattern that is forming out there. Because if there's a pattern, so your systematic random sampling is really not random at all, because there's a pattern. So that is how we use the systematic random in illustrative purposes. For example, if our k, which is the kth element, is 3, so therefore we choose every third participant in our study. So we skip count 1, 2, 3. We get this person right here because he's the third person. And then we do that continuously. 1, 2, 3. Okay, we also get this name here. So imagine that we're gonna do that on a list. Okay, so that's how we do systematic random sampling. And what's the procedure? A sample procedure here. So first, you need to determine your sampling interval k. There's no actually generic formula for your k or your sampling interval, but there are suggestions in some books that your k should be population size, big N, divided by your sample size, small n. In particular, you already have your sample size in determining your interval. You just need to round this to the nearest digit or interval. Okay? After you know your k, after you know your skip count k, you need to identify your random start, R sub s. So your random start, from the word itself, it should be random. You can ask someone not related to your study or not a co-author of you, just produce you a random number from this 0 to your kth interval. So just let it be random as much as possible. Nicely, it should be random. Determine the number of elements to be included in the sample. So the first one should be, of course, your random start, because you will start in that certain participant. The next one should be your random start plus your interval. So particularly the next parts of your sample should be where the skip counting part starts. Okay, so that's how we produce it. So first you determine your k, what's the value of your k, population size over sample size. You produce a random start, and then from that random start, which is below k, but of course greater than 1, from that random start you skip count from that random start, given your k value from number 1 step here. So to give an illustrative example, let's say you have your population size to be 10,100, and the sample that you need is only 150. So to get your number 1, your k, your interval, you divide big N over small n, population size over sample size. This is equal to 10,100 divided by 150. This will give you 67.3. So we don't have a 0.3 person, so round it off to 67, simply 67. From that, you randomly choose a number from 1 until 67. Okay, that number may be produced by anyone, not by you, not by anyone affiliated with your research, as long as it is random. You may ask your someone beside you there right now, you may ask your baby sister, brother, or whoever. Okay, as long as it has not he or she has nothing to do with your research, or it doesn't know anything about why you are asking such. So for example, we have randomly chosen the number 43. Okay, so 43 thus will be that random start, that will be my first participant, the 43rd person in that sampling frame, in that list. Okay, and then after that, the next participant would be 43 plus 67. Okay, that's gonna be the 110th participant. And what will be our next participant? So 110 plus 40 plus 67, that's gonna be the 177th participant, and so on. So until I reach this 150 participants all in all. Okay, so that's how systematic random sampling um, happens. Next, we'll talk about stratified random sampling. This is a common one um, sampling technique that is used. This is stratification. So this came from the word strata. Okay, strata means a group of persons or a group of participants wherein they have a common denominator or a common characteristic. So for example, if you want to get a representative per strata, say for instance, sex. So you want a representative in the males, you want a representative for the females, so you use stratified random sampling. Basically, in some books, they have two more types of stratified sampling: the equal, if the word is correct, and the proportional. By default, we use the proportional always. We only use stratified when the population itself is heterogeneous, but it can be subdivided into homogeneous strata. Okay, so this heterogeneous population can be subdivided into homogeneous strata, as singular stratum, so that we will have a representative per homogeneous strata. Okay, and we want the representatives um, to be proportional to the total number of population per strata we have. We also need that there is a sampling frame or a population list per stratum. And for certified random sampling, this is our procedure. First, we need to determine the proportion for each stratum relative to the population. So we should have that information as well. So for example, if you want to determine, say, grade 11, grade 12 students, so you should know how many grade 11 there are, how many grade 12 there are, and how many they are in total. And then identify the stratum sample sizes by using the proportional allocation. We're going to do that in a while. And we're going to select samples from each stratum using, the point of stratified random sampling is that it does not give us a way in gathering the sample sizes. It only tells us how many samples we need per stratum or per stratum. Um, at the end of the day, after stratifying, we still need to know how we will gather the data. So we can either gather the data after determining the sample size per stratum. We need to use either simple random sampling or systematic random sampling to generate or to gather information from this generated data or generated sample size per strata. So this is one example which we will answer right after this video so that we will have a straight discussion. Among 250 employees of a certain company, 182 are Filipinos, 51 are Japanese, 17 are Europeans. If we use proportional allocation, stratified random sampling, we need to select, how do we select stratified random grievance committee, which is composed of 15 employees. And the question would be how many employees must we take for each race? So this is similar to your, for example, for your research problem. Say you want to gather the mental health level, if that thing exists, mental health level of grade 11 and grade 12 students, and you want them to be represented proportionally. So since there are a lot of grade 11 than grade 12, for instance, so you need to take more of grade 11 than grade 12 because they represent more of the population than of the grade 12. So we're going to go back to this. If you want, you can take a screenshot and answer this on your own paper, and then we're going to answer this later on. Okay, I'll be moving on. Now, for the cluster random sampling, in some books they call this also as area sampling because most of the case, though not all the time, when we cluster sampling, we talk about area or geographical area. Okay, so this is selecting clusters of elements rather than individual elements. So we use this usually when there are natural groupings that are evident in the population. So there are already homogeneous groupings which are natural, which we don't need to alter anything at all. And compared to its other parts of the probability sampling, cluster random sampling is or can still be done. It's random, though you don't have a sampling frame. So take note of this second assumption, that you don't need to determine, or you don't need to have a sampling frame or a list of everyone in the sample. This is actually one of the great things about cluster random sampling. You can still gather, or you can have still randomness in your data, in your sampling procedure, even if you don't have a sampling frame. So that's important because it's the only one that doesn't require a sampling frame. SRS requires one. Systematic random sampling requires one. Stratified random sampling requires one. So if you want to have an inferential analysis in your statement of the problem in your research, and but you don't have a sampling frame based on any reason whatsoever, ethical reasons or something, this cluster random sampling is the go-to. Okay, so what's the procedure here? You divide the populations into clusters. We call those in this book M, which is what else? Fishbowl. Um, what's the other name? Lottery method or random number generator. And then you, therefore, after determining these clusters, you include all the members within the selected clusters into your sample. You don't need to do anything, but you need to include all of them. So we call it cluster sampling. Though cluster and strata are both non-overlapping, non-mutually exclusive subsets of the population, they differ in different ways. I want to clarify this because seldom there are confusions between a stratum rather, and a cluster. So take note of these. Bullet 1, with stratified sampling, the best survey results occur when elements within strata are internally homogeneous, whatever that is pronounced as. However, with cluster sampling, the best results occur when elements within clusters are internally heterogeneous. Okay, so therefore, um, if we have, if we want to have homogeneous, if we have homogeneous groupings, we may as well use stratified sampling. But when we have groupings which are heterogeneous, we might as well use cluster sampling. So the purpose why we use stratified sampling is that we have um, a proportional allocation, a proportional representative per strata or per group of this homogeneous grouping. The purpose why we do cluster sampling is that in the groupings themselves, we are sure that there's a mixture of different representations of the data. So we are sure, since we know that they are heterogeneous, so we have already mixtures of representation. So we don't need to regroup them, because when we cluster, when we gather one cluster or one group, all the different all the different characteristics are there already because they're heterogeneous. So for example, if we're going to talk about stratified sampling rather, this is one example. Say we have women and men, and then from these women and men, we want representatives from them. So that's what when we use, for instance, stratified sampling. But for cluster sampling, for example, we have presents, voters from, say, for example, we have 32 states or 32 cities in this illustration here. We know that in each precinct or in each location, in each locale, we have representations already of different walks of life. So we don't need to do a stratified sampling, because if we're going to get one group or one locale, we're going to gather everyone in that locale, we will have a pretty much proportional representation as well. So we don't need to regroup them. Just choose certain clusters, randomly choose them, randomly pick the clusters, and interview or gather data from everyone there. So those are the appropriate times whether we use a stratified sampling or cluster random sampling. Take note, these are random sampling still. Okay, now for the multi-stage random sampling, we have these. So we have actually for the multi-stage, in some definitions they say that it's a combination of any of the four. Actually, that's a wrong definition. Multi-stage random sampling is just that it is cluster sampling or area sampling, but done in multiple stages. In cluster sampling, we only do it in one stage. Okay, we randomly pick and then that would be all. Okay, but in multi-stage, we don't stop with one stage of clustering. We can do it in n times. Though, and of course, multi-stage sampling is flexible, it's cost-effective, and it's easy to complement. Rather, it's easy to implement. Rather, you can use as many stages as you want to reduce sample size to a workable size with no restrictions on how you divide the groups. Okay. However, seldom this method has a subjective component, and it is known to be less accurate than simple random sampling. So, though the simple random sampling is the foundation, it's the most basic, but it's actually a powerful one. So for multi-stage sampling, examples, the Gallup poll uses multi-stage sampling. For example, they might randomly choose a certain number of area codes, then randomly sample a number of phone numbers there within each area code. So that's an example. There are two stages here. Here, number two from the research of Johnston et al. Survey on drug use in high schools. Excuse me, used a three stage sampling. So first geographical, they choose a locale, and then followed by choosing high schools from those locales, and then followed by choosing senior high school, say, sections in those locales, in those schools rather. So that's how they use multi-stage sampling. Okay, so that's it for now. That is Those are examples of probability sampling. So let's just have a recap. We have talked about simple random sampling, stratified random sampling, cluster random sampling, and multi-stage random sampling. I hope you have learned quite a lot after that. Thank you very much, and I'll be seeing you next, since we will be talking about non-probability sampling right after. So see you.